All right. Trig lecture 11.8 and 11.9 today. The student will use the law of cosines. Last week we used the law of sines to find measures of indicated angles or sides for given oblique triangles. Today we're going to use the law of cosines. The student will use the law of cosines to find the measures of indicated sides and angles for given oblique triangles. And it'll work for right triangles too. But if the angle isn't a right triangle, then we can jump to the law of sines or the law of cosines. The way I determine, the manner in which I determine whether I'm going to use the law of sines and the law of cosines, it may not be, the best way, but it's how I do it. When I go to find a missing side or angle in an oblique triangle, I always try the law of sines first. I look to see if I can set up A as to sine of A as B as to sine of B, so forth. So I'll see if I can find a proportion. If I can't, then I jump over to the law of cosines and see if I can solve it using the law of cosines. So I'm going to show you how the law of cosines works. We use the law of cosines. We're going to find the measures of indicated sides and angles. We're going to round to the nearest tenth. And there we go. Here's the law of cosines. The first one is a squared is equal to b squared plus c squared minus 2bc cosine A. The next one is just variations of that. B squared is equal to a squared plus c squared minus 2ac cosine B, and so forth and so on. These are the three we're going to use, and which one we use is determined by what it is exactly we're looking for. They're all very similar. If you just analyze these for a second, you see how similar they are, and I'm going to just apply them to a couple of triangles to give you the idea of how we choose which one we're going to use. So here we go. I'm going to be appealing to these. These are the laws of the law of cosines. I have this one memorized, and from this one I can derive these two very simply. Find AB. Now remember, back in geometry, AB, if we saw it like this, that means line segment AB. If it's like this and there's no symbol above it, it means the length of line segment AB. So what it's asking you to do is to find the length of line segment AB. So I'm going to look at this figure right here. I see here's what I'm looking for, the length of this segment. So I'm going to name it small k C opposite the angle which is named C. So I'm looking for side C. So I'm going to use this iteration, or this form of the law of cosines. I'm going to say, well, C squared is equal to a squared plus b squared minus 2ab cosine C. I'm going to plug in everything I know and then solve for the one that I don't know. So here we go. C squared, I don't know. That's little c right there. And there's a large C, capital C. That's the measure of the angle. C squared is equal to a squared is what? 16 squared plus b squared is 20 squared minus 2 times 16 times 20. A is 16 and B is 20. Angle A, side A, angle B, side B. Cosine C. Whoops. Got a little spastic there. Times the cosine of C. And C is 68, so I'm going to plug in the 68 there instead of C. Now all I have to do is get all this into my calculator, and that will give me C squared. I don't want C squared, I'm looking for C. But if I know C squared, I can just take the square root of that, and I'll be looking at C. And then I'll round it to the nearest tenth. So I'm going to get my handy dandy pocket brain and evaluate this thing. And I'll say C squared, or C is, I'm going to enter all of this into the calculator. That'll give me C squared, and then I'm going to take the square root of it, okay? So here we go, that's 16 squared. I'll try not to mess up plugging it. You got to be careful when you plug it into the calculator because it's easy to hit the wrong button. So I got 16 squared plus 20 squared minus 2 times 16 times 20 cosine 68 degrees equals I got 416.25, blah, 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 goes, it leaves my screen, goes on forever, never repeats. I'm gonna take the square root of that because that's c squared. All of this mass is c squared. I don't want c squared, I want c. I want the length of this line segment, which is c, not c squared. So I'm gonna take the square root of this, boop, equals 20.4. And that would be centimeters or inches or whatever, meters. And that's providing I haven't made an arithmetic mistake. And let's see what the answer key says. The answer key says 20.4 meters. Okay. So what did I do here? I was asked to find AB, and I appealed to these three. And the reason I chose this one is because it said find the length of AB. I analyzed this briefly and said, well, that side AB is opposite angle C, so I'm going to call it C, and use this one. Okay. So there we go. That's for finding a side. If I'd been asked to find a different side, for instance, if I was looking for this side, I would have chosen this one. I'd be looking for side A. Okay, so that's how it works when we're looking for a side. Here's how it works when we're looking for an angle. Find the measure of angle B. So I look up here and I say, well, this is the angle I'm looking for. So I'm going to plug in everything I know into this one. B squared is equal to A squared plus C squared minus 2AC cosine B. Because I'm looking for B. I know all the rest of them. Okay, so here we go. Let's plug in, and the reason I chose this one, because it said to find angle B. Okay, now these are for triangles that are labeled A, B, and C. If this triangle was labeled, I don't know, W, X, and Y, we would say W squared is equal to X squared plus Y squared minus 2XY cosine W. Okay, it doesn't have to be A, B, and C, but for triangles named A, B, and C, this is what it will look like. All right, so I'm going to start plugging stuff in, and I'm going to be looking for this. So here we go. B squared, that is 16 squared, is equal to A squared, which is 19 squared, plus C squared, which is 10 squared, minus 2 times A, 19, times C, which is 10, times the cosine of B. Well, I don't know what B is, that's what I'm looking for. But now I've got something with only one variable in it. So here's the plan. I'm going to get cosine B by itself by using simple algebra. I'm going to subtract 19 squared, subtract 10 squared, and then divide by negative 2 times 19 times 10. And that will leave me with cosine B, alrighty? So that's what I'm going to do first. It'll look like this. You don't actually have to show this part, you can do it with your calculator, but what I would enter into my calculator, 16 squared minus 19 squared minus 10 squared divided by, and I'm isolating cosine B, so I've gotten rid of these, divided by this mess right here, divided by negative 2 times 19 times 10. This will equal, here's my equal sign. This will equal the cosine of B. And I will try to make that a little clearer. I subtracted 19 squared from both sides. I subtracted 10 squared from both sides. That 10 squared right there. Okay, so now all that's left is this. And then I divided by this. And it wound up in the bottom. So I wound up with this, divided by this. because this whole mess is multiplied by the cosine of b. Now I just got to figure out what this is right here and take the inverse cosine of it. I don't want the cosine of b. I want, oops, I want b. See if I can move this. There we go. So I'll go ahead and say that b will be the inverse cosine of this. This is the cosine of b, this mess. So I want to find out, well, what is b? The inverse cosine of this. So I'll say b is the inverse cosine of this mess right here. 16, you don't have to write all this down. I'm just showing you what's going on in my head before I just start plugging stuff into my calculator. Oops. Now you have to be real careful with your calculator. You can do all this and hit equals, then divide it by, and it would be a real good idea to put this whole thing in parentheses. Because if you just say divided by -2 times 19 times 10, it'll divide by -2, perform that operation, and then multiply the rest of those by 19 and 10. And we want all of this divided, not multiplied. So I want the whole thing divided. So here we go. Let's see if we can get it into our calculator. We got 16. I'm going to say what I'm putting in there. You don't have to do it this way, but here's how I would do it. 16 x squared minus 19 squared minus 10 squared equals. Now I have the top of my fraction in there. And if you wanted to write it like this, here's the top of my fraction. Simplify. Divided by, and you could multiply all this together, you know, and then take the inverse cosine of it. So I'm going to put, yeah, we could do it like that. You might like to do it like that. This is 2 times 19 times 10, and it'll be negative. Well, 10 times 19 times 2, that's what, 380? Is that right? Let me do that. 2 times 19, because it's early in the morning, and my brain is not very good at the best of times. Okay, so I got -205 over 380. That's the cosine, the inverse cosine of this. This is equal to this. So now what I'm thinking is, think of this as a thought bubble, or you can actually write it like this if it makes you more comfortable. The cosine, the inverse cosine of this will give me b. So let's see what we get there. Negative over negative is positive, so I'm just going to say the inverse cosine of -205 over 380. 205 divided by 380 equals, I'm going to take the inverse cosine of that, equals, I got 57.4, so we measure of angle B. And that's rounding to the nearest tenth. Now hopefully I got that right. Yay, I did. It's very important, if you're going to just type this straight into the calculator and not do the way I did it, I'd said, well, here's the top of the fraction, here's the bottom of the fraction, now we can take the inverse cosine of this. You may want to do it that way because you'll be less inclined to make mistakes. But if you want to type this whole thing in and take the inverse cosine of it, make sure that you put the bottom of the fraction, the whole thing, in parentheses. It would be parentheses -2 times 19 times 10 parentheses parentheses. Okay? So make sure you do that. And that is using the law of cosines to find a missing angle. You plug in everything you know, isolate your cosine b, subtract, then divide by whatever's being multiplied. This is -2 times 19 times 10 times cosine b, so we divided by this to isolate cosine b. Then we get this in the calculator and take the inverse cosine of it, and that'll give us the measure of angle B. Okay. Getting this into the calculator may be tricky. If you're not careful, you'll get the wrong thing in the calculator. You can do it like this, or you can say, okay, well, here's the top of the fraction, here's the bottom of the fraction, simplified, and then take the inverse cosine of this, enter it into the calculator like that. In any event, you can do this using the law of cosines.